So let us continue. We are on example 32. So a market research group conducted a survey of 1000 consumers, and it reported that 720 consumers would like product A and 450 like product B. So what is the least number that must have liked both products? In this, what we're going to do is we are talking about U, that is the universal set that we will understand to be consumers which are questioned. S is the set of customers who like the product A, and T will be the consumers who like the product B. And we know this NU is 1000, these are being surveyed, and S is the 720 consumers that like product A, and for product B it is 450. Let us directly go down to our expression. We know about this, so we'll place the value, and by now we know that this S union T, number of S union T, is equal to 1170 minus NS intersection T. But we have been asked some other question. In this, please observe that NS union T, this is going to be maximum when this is going to be minimum. This will be least. So if it is 0, it will be 1170. But we also know that this S union T is also the subset of U, which implies that the number of elements in S union T can never be more than 1000. Can never be more than 1000. Okay, so maximum values of this NSUT is 1000. So the least value is what? You just subtract 1170 from 1000, and that will be 170. So the least number of consumers who liked both products is 170. Next question is, out of 500 car owners investigated, 400 own car A, 200 own B, 50 around both A and B. Is this data correct? Let us see. The universal set is 500, the M1 is 400, the S1 is 200, and the intersection is of course given as 50. Let us keep these values in this formula or this expression. We find that the value comes out to be 550. 200 plus 400 minus 50 is 550. So this S union M is this subset of U, which implies that this S union M has to be either equal to 500 or less than equal to 500. It cannot be more than 500, which is this case. So the data is incorrect because we see the contradiction here. Next is, a college awarded 38 medals in football. So for F, we have 38. This is F. Then basketball, B is 50, 20 in cricket. So C is our cricket. So if these medals went to total of 58 men, so total is 58. Only 3 men got medals in all the 3 sports. 3 is the intersection of all these 3. How many received medals in exactly 2 of these sports? 2. So let us see. We know this formula. We'll place this value. The F football is 38 given. The basketball is 15. The cricket is 20. And the union of F union B union C is 58. So this intersection, because 3 medals have been given to those who got in all these 3. So intersection is 3. Let us place it in this expression, and F union B union C is equal to NF plus NB plus NC minus F union B minus F union C minus NB intersection C plus NF intersection B intersection C, and we find that the answer will come as 18. This one. But here is something. This is, say this is A, so A plus D. This is D plus B, this one, and this is D plus C. So this portion is what? This is the area which we want. So actually it is A plus D plus B plus D plus C plus D, and we have got 18 as here. So the D is actually 3. So what is that? A plus D, B plus D plus C plus D. It is actually coming to 18, which we just got here. This is actually 18. But we see that D is actually added thrice, which is the intersection F intersection B intersection C, which is 3. So 3 plus 3 plus 3, 9 is added extra. We have to subtract 9 from this. So A plus B plus C is 9. So this is the number of people who got medals exactly in two of these three sports. Now let us summarize what we have learned in this total first chapter. So this chapter is very important because it deals with the basic definitions and operations which involve set, and we can summarize it like this. A set is well-defined collection of objects, and a set which does not contain any element, we call it as an empty set, null set, or void set. So a set which consists of say a definite number of elements is called finite set, otherwise we'll call it as infinite set. And two sets A and B are said to be equal if they have exactly the same elements, and if set A is said to be subset of B when every element of A is also in B. And we have also talked about the intervals, that is the closed interval, the open interval, and the combination of these. So these are very important when we are dealing with the value. We want to include that value in our computation, or we just want to be there but don't want that value to be there. So it is actually less than or less than equal to situation, or like that. This is just one expression I said. This is a logical expression. Now we come to the power set. Power set is what? It is actually the collection or combination of all the subsets of A. If you have a set A, make all the combinations, and these combinations are going to give you the power set, which is denoted by P, and in the bracket it will be A. The union of two sets, because we know that we can do operations on set also. So union, intersection, and subtraction, all these we have seen. Also the complement. But the union means we combine the values which are there in A and B. Values, whenever I'm speaking values, you understand element, because the elements are actually the content of your set. So set A, set B, take the elements, combine them together, and just remove the duplicacy, you will find the union. So union is actually corresponding to the addition. The intersection, you can say it is a sort of multiplication, you can say, but not exactly. Intersection of two sets A and B is actually the set of all elements which are common. So you take set A, you take set B, those values which you see in both the sets, these values will come in the intersection. What about difference? Difference means you remove all the value from, say, if it is A minus B, you remove all the values of B from A. You remove all the value of B from A, and if you want to do B minus A, then you remove all the element of A from B. That will be your subtraction. What about complement? Complement means not that set. So apart from that set, everything will come in complement. So it is represented by A dash. Complement is given by A dash. Anything which is other than that set in the universal set is the complement. Then for any two sets A and B, this is very important because it is corresponding to the De Morgan's law. So A union B complement is equal to A dash intersection B dash, and A intersection B dash is equal to A dash union B dash, and see this union and this intersection on the left and right hand side, they are changed. If A and B are finite set and we say A intersection B is empty or null, if it is not empty, the formula would be like this: A union B is equal to NA plus NB, and then it will be NA intersection B subtraction. But if this is phi means it is empty. So what we are going to do is NA union B will be exactly equal to NA plus NB. So this was all about the chapter sets. Thank you so much. Take care.